Question 3, we've got a capacitor or two capacitors in the circuit with a resistor, and the switch closes. One of the capacitors is initially charged and one is initially uncharged, and we'll get to the question shortly. I won't preempt what I'm doing. In the circuit shown, a capacitor C1, which is holding a charge Q, has an initial potential difference of V0. Capacitor C2 is initially uncharged at time equals 0. The switch is closed. So the question is, explain what changes will take place to the charge on each capacitor and to the potential difference across each capacitor. So we've got to deal with the charge on each capacitor. So if we're dealing with the charge, we'd look at C1 and then we'd look at C2. If we're dealing with the voltage across each capacitor, we'll deal with the C1 and for C2. So this is kind of using a table idea to divide the question up to make sure I cover all of the important information. Another way of looking at it is, for each piece of information, the charge and the voltage, those are the two pieces, I have to provide two other pieces about each of the two capacitors. So, what changes take place? And let's look at this circuit in general, and then we'll look at it specifically for each of those things. So, in general, as the switch is closed, this charge is going to try and balance it out. So some of the charge will go this way, some of the charge will go this way. So like if we imagine that there's a positive build-up on the left-hand side and a negative build-up on the right-hand side, then that's going to balance out, and we'll have in the final state we will have, say, two of those and two of those and two of those and two of those. Okay, so it'll just balance out. You'll have current running through the resistor. There will be a certain amount of energy lost due to heat as that occurs, and if we're dealing with the voltages, the voltage at this point is going to drive the current around, and then we'll get another voltage across here. The voltages, are they going to be equal or not? Don't know. Let's have a quick look at this. There's the formula Q equals C times V. We know the capacitance can't change, so that's just going to stay the same. But the charge on C1 is going to decrease. That means the voltage on C1 is also going to decrease. So that tells me that the total amount of charge can't change, but the sum of the two charges will add to produce the total. That means the voltages of the two will add to produce the same total. So the voltage is going to divide up, the charges will divide up, and that'll be according to the values of the capacitances. In any case, that's the overview. Let's have a look and see what happens. So the changes, remember we're dealing with the changes, so these are all changes that take place to the charge on C1 and C2. So it's going from one thing to another thing. So C1, this is C1 at the top, and this is C2 at the bottom. C1 will go from charged to less charged. We might call that Q1 final, and that'll take place according to what do we call it? The time constant and the resistance. The resistor will affect how much charge passes off that, as well as how much charge goes onto the other one, which is interesting. There's a lot of questions you could explore there, but that's getting beyond the bounds of this. C2 is going to go from 0 to, it's going to build up charge, Q2F we'll call it. When we're dealing with the potential difference, for C1, the voltage, initial voltage, is going to go to some sort of final voltage. It's going to decrease, and that's on C1, so we'll leave it. And C2 is going to go from 0 volts to where are we? To a final voltage. It's going to increase in voltage, and that's, I guess, the main points of all of that. What I was going to say before is, if you want to explore further, you could explore whether the time constant is going to be the same for both capacitors, since they run through the same resistance, and if it is the same, which value of C do you use? So if you wanted to experiment with that, you would create a couple of circuits and just test it out, I guess. So you'd create the circuit above, use various different values of the capacitance, and measure the voltages and time it to see what happens, and then that would inform how you would look at it mathematically and all those sorts of things. Anyway, that's more than enough for this question.